Welcome back, guys. So today, let's start with where we left off last week. Last week we managed to finish a little bit of, overall changes around the block read and block write to make it more dynamic. Because we had some hard-coded indexes, those things were moved and everything were changed to dynamic, so you can just call multiple times and it should work just fine. We tested it sequentially, not parallelly, but still it should work fine. But after that we realized that lots of code that we own currently needs to be synchronized because kernel can support multiple processes and sorry and they are supposed to actually walk parallelly, and especially when multiple processes can write to same file, there should be some sort of synchronization happening in VFS layer and also in block layer. And we confirmed that we do have some races which currently are not an issue, because currently we are testing it only with sequential code in kernel context. There are interrupt context that could potentially want to write something which is not idle, because I guess people try to keep the interrupt context as small as possible, but just in case if it tries to get the lock, it should not put into a deadlock position, because if the lock is already held and you are trying to catch the lock within a interrupt context, then within interrupt context you are never scheduled off, so it's a deadlock condition. So overall today we are gonna implement, and we also guess saw how exactly to implement the spin lock in general with ARM instruction, which are almost specifically made for these kind of atomic operations. And the atomic, I don't know why the something's wrong. I don't know. It's the dust. Maybe. I guess my window is fully open, so I guess it's the dust. I'm not sure. Whatever. Sorry, guys. So as I was saying, we are supposed to write the spin lock this week, and we went over the theory of the spin lock in the last session. You can check it out. And overall, a recap of what we are doing is that we are trying to write our own kernel, and we have the MMU unit working, and we do have the scheduler. We have a little bit of virtual isolation for the kernel context and interrupt context. Everything is working perfectly. We also have the block layer working, which can write to currently to X4 through which IO. And other than that, we are gonna implement the spin lock today. So let's see. And as we learned last week, we want mutex, but then we realized that even there are some design choices that we need to make mutex is not always the best decision, because mutex yields the CPU, and sometimes we don't want to do that. Sometimes we would just want to hold the CPU for a while and do the stuff, so that we don't yield off and go through that entire context switch. Sometimes the context switch is actually not worth it, and it's costly, and in those particular cases it's better to have the mm, spin lock. So we just keep using the CPU cycles without doing anything until we actually have something to do. So let's see. So we have mutex.hatch. Maybe we could just rename it. I guess currently we're just gonna use, and it's going to be spin lock. Wait, what the fuck happened? Okay, I already have a little bit of definition here. Okay. And okay, we have the spin lock, and it's going to be closed. And we do have a little bit of theory here. In case we just log, get the critical session locked, and no interrupts. So yeah, we also learned that we have to tell the scheduler that inside a critical section we are not supposed to be scheduled off. So whenever we get into a critical section, we have to do this some sort of signaling to the scheduler to turn off the interrupts completely. So completely you just mask the interrupts when you get into a critical section, and you mask and turn on the interrupts again when you exit out of the critical section. So no matter what, that you will not be interrupted by anything. I mean literally anything, but I think that is bad in a way. So this critical section should only be used wisely, I suppose. Because what if and one more thing is that if we are using spin lock, we should make sure that we are not using anything that can actually break, because spin locks are containing we're just using CPU fully, so we are not supposed to do anything super critical. We are here to hold off someone else from doing some operation that is really fast, like maybe increment a global counter, or increment saying that I have the lock now, because that operation is just probably um, one bit being set up or down. And these are the kind of operation that needs to be put inside a critical section, so that there is no real critical issues when we actually mask off those interrupts. Okay, let's try. Okay, so we want spin lock and spin unlock, and spin lock is a simple uint8 value with lock being the only fields. you know whether it is being held or not based on the output. It can either be 0 or 1. 0, let's say it's not locked. 1, it is locked. Okay, what else can we do? I think we don't need anything else. We can start implementing this. Yeah. Let's. No, not that. I need a new file and it's called spinlog.c. Okay, and we're gonna include, I think we can include it directly, spinlog.h, and maybe we'll also include stdio, stdint. We don't have standard library. And then we can start with spinlock. We can just copy both things here, paste it, need it for the signature, nothing much. Open it and close it. Why does it not see bool? What did we import for bool to work? I don't know. We have standard int.h. We don't want to because we are including that. How is bool not implemented? Okay, whatever, we'll think about it later. Let's just also, if there's any error, we want to say something. So I think let's call it int 8, so that we can return minus values, negative values. And okay, we do now, we just simply, we need to run it. Where is my, this, maybe 1, maybe 2. Okay, 2 looks good. Okay, we can run it here. Return 0, return 0. Okay, we return both of it. Now let's just update the, let's remove all camos. It's fucking annoying. And we go to our builds. We come here, we check this, check that, and we add the core spinlock.c, and we can add here spinlock.o, and let's run it and see nothing breaks because we didn't add anything special. We just have some boilerplates. and it works. So let's go back, and we have a spin lock, and it fits, and it's supposed to be inline assembly because how else can we actually make sure that we have the specific instructions that we want? And the instructions that I am talking about is this is what we last time we checked. So what we are going to do is we're going to use load XR and str. So what happens is you take something from memory using this operation, this instruction. If you take something from memory using this instruction, that means internally it will tag that memory location as exclusively used. So it says that marks the address as exclusively accessed. So this whatever memory location we try to access with this has some sort of tagging, and then you can just check if it's whatever value, red is whatever it is, and then when you want to write back you can use strxr. And if you use this and let's say that memory location was modified by someone else, this operation would just fail. And if it passes, that means nobody else updated this during during this whatever phase, during this instruction. We even if we got scheduled off to some other process, whatever happened, this memory location hasn't been updated or been touched, so you can simply update it. And this is also atomic. So this is what we want. We want to read from a location, and we want to be sure that it's not being accessed at all. And I think there is atomic keyword in C, but I don't know if it will work here. Do we have atomic atomic variables in C? Is it part of standard lib, or can it be used as freestanding? Freestanding as in we don't need I think maybe it is possible to simply write this. If this is possible, then we don't really this the same thing that we want to implement. Maybe do we want to implement it, or can we use atomic? Guarantee equals works across all processes or just within the thread. Because I want to know if this atomic operation is only atomic for this particular single processes. So I think this was supposed to be within memory. But if our mm, process, which is kernel, is already in the kernel context, then that context is being shared by every process. So I think we can use atomic and still get the same thing, even in our context, because our kernel, because in my case it's just that we have multiple user processes that can try to access this. So if but they access this through the kernel, and the kernel has only one context, and within that context which this memory is going to be alive. So maybe we could just simply use atomic, or do we go for the or do we go for the other approach where we can use assembly? I don't know. I think we'll just go with the assembly, because that way we can actually infer how it is. I mean, we can try to use the atomic and see the assembly instruction, how the compiler does it. Maybe we let's implement one with atomic. Then I have to actually mark it as atomic. That's another headache. I don't want to deal with it. So let's just inline this. Mark a C function as assembly in inline assembly. No. To write as inside a function. And I want to read the parameters. I mean, I can use just ASM. Okay. I guess that's what we are gonna do. We're gonna define a result variable, and it's going to be int32 result, and result is always starts at 0. And then we're gonna have the ASM block. It's just 2. Okay. And we can write it and also mark it as memory, because I remember we have to mark it as memory, if not, because this deals with memory barriers, we need to mark it as memory too. So in general, what we need is we need load instruction, and we need example with memory. Maybe we need to add volatile. I don't know if it is gonna make any difference, but yeah, why not? We'll add it. and we want LDAXR. And we want to read from a location X0 and write to W1. I guess it's word level access, and it's %1, maybe it's the first variable. Not this. I need to see it in yeah. So this is what we do. We here %0 is going to be a register, and those two registers are added with 1, and the register is stored into 2, and 1 is source and 2 is destination, and finally we say that it is gonna clobber memory. And we also store it in temp. Yeah, this is outputs and this is inputs, and this is what sort of operations are going to be done. So in our case, we don't have to specify any register. Then let's just use, so it's going to use a random register here, and it's going to take the first operation. And do we need to put /n/n? Okay, whatever, we'll put that. And then once we have it in a register, now we have to compare it, and we want to check if it is equal to 1 or not. If it's equal to 1, then someone has the if someone already has it, where will it jump? Compare and jump not equal to properly. So it's going to compare this with this. And go directly here. it returns 0, where will we jump, which intersection? Holy fucking moly. So it is supposed to jump to second value, which is the label. Okay. Okay, we jump to J label. Then I have to define the label here. CBN is it? I check this register. If it is not good, where do I jump? If it is not 0, that is to go back to the previous section. In C ASM. Okay, we just defined that it in front of it. Okay, so we say loop /n/t, and this is the first operation. If it is not 0, we jump to loop. That is good. But if it is 0, then we go to the next operation, that is move source and no, move 1 into source. Okay, I cannot do this. I have to just move %0. This register, I just move 1. And then I can use the store operation, which is store XR something. LDAXR. STLXR. STLXR, and we store into this. What do we store? We store whatever that is in 0. Now this operation should fail. Okay, it also has a new value, that is the result, and then again we can check and go or do whatever we want to do. So we have another variable that is going to be %1, no, %2, and the input is %0, and output is the address within %1. This is going to be our thing, and I think that is it. Now we can just what do we do? Maybe we don't have to do the loop here, because we simply check the value. If it is 0, we update it. If not, we just exit. I think this is also good, because here then we don't have to write any loop outside. It's always going to loop. It's going to read as long as it is 0. It's keep on gonna looping, and then it's going to move 1 and it's gonna write. And what if this operation fails? Then we're just gonna get the output as that. Then maybe we have to write in another condition to go back here, so that we keep doing this indefinitely until we actually able to lock it. Okay, that is also possible. Now we have the other condition saying if 2 is not equal to 0, we again go back to loop. And now we can actually write the inputs and outputs. First we have to put output. Output is going to be R, and it's going to be put inside result variable. And we have input. Input is actually just 1. It's going to be current value, and it's uint8 current. And it's going to be register. one is going to be a read register. So let me put reads, and the register is current, and we have another register which is results. And finally we have the memory, saying that it is going to update the memory. Whatever in this address, and it needs to be address. So it's lock. We have variable, and we take the in that case, I guess we need to just pass it here like this. Address of lock.lock, that is going to be dereferenced here and stored here, and it's going to be checked and looped again, and then we write it back, and we try to update the lock value with the value in first register, this register, and then store the output here, and we use that to loop back. Well, looks good. The final result value is actual value, so we don't need any reference. Here we need the address because we dereference it. Okay, let's double check this. What's wrong with our approach? What? So we don't need this. I have 1 and 2. Okay, because 2 is only used as output, maybe we don't have to specify it here as input because it's already assigned here. Why? So we load the lock into temp. If it is not 0, we loop back. If not, we set temp to 1 and try to write it. And the value is also written into register. And we check if it is equal to 1. If not, we jump back. And output is only written into one value. So our input is correct. We are using the address of the lock, but the output is wrong because output. Why do we need our output? temp assigned as reference in output block. Understand the use of shouldn't it just temp. Oh, okay. Here in that example, the temp value is already assigned. In my case, temp is not assigned. Temp is just thing. I think if I just remove this, my example. We take whatever that is in this and we put it here. We check it. We again write whatever that is in here into this and store the output into how do we define two? For one actually means it's taking the first register, I guess. And then what happens if we want two registers in right? How do we define them? Maybe it's not possible. Yeah, the output just directly goes into this temp. I think this is all. This is good enough. I think it should work. There is no current. How about now? This should be good. So zeroth register should also be actually given by us. Okay, then I'll do this. Int 8 temp to 0. So now we have whatever that is in here is written into temp, and we looped, and one is written into temp, and then we store whatever that is in one into 2 and store the output into 3. Will this work? How about now? I have 3 operands, 2 inputs, 1 output. Why the fuck do I keep getting the same fucking thing? Okay. I didn't ask you to optimize it. Is my current version work? I'm fine with having 3 operands. Okay, so tell me why you are using 2 in assembly temperature. Okay, this is operand 0. What is define operator press? You should have explained this, you fucking piece of shit. So it's going to be temp here, and be both out input and output. How do I define it? Oh, here I have to specify which outputs, and then I can say it here. Okay. My outputs is and I also read from them. So I read from 3 and write it to 0 temp, and I check it, and I move 1 into temp, and then I move and I try to write whatever that is in temp inside 3 and store that into 2 into 1. Okay, now is this precedence correct? Is this operand numbering correct? I'm not sure if we mark something as read and write. Should we increment the operand count to yeah, 2, which is same as 0. Okay, then now it's the implementation correct. Oh fuck me. Oh fuck. Why the fuck do you main issue is that you are using 2 variables, temp and results, for the output, but No, it is not. I am loading from memory into... What the fuck am I doing? Into register 0. That is temp. Then what do I do? Finally, store from temp, wait, into address, that is 3, and store this result into 2. Why is this wrong, you piece of shit? One and two are the same. Read and write. You fucking piece of junk. That's why you fucking don't believe this piece of shit. First of all, it's not a piece of shit. It's not even saying anything. It's just throwing in tokens to me. I don't sometimes fucking forget that they don't answer. They are just tokens. Nothing much. It's I am supposed to interpret the results. There is no results. I think I'm just gonna test it. We are to test it. We ought to test it. Let's go into core. And let's see. Clang. Spin lock. That shows spin. And then we say int I equal to 0. First we say lock spin lock L. We lock it. We lock it, and then we increment I plus plus, and we don't have code to unlock it, so we'll just see if it worked. At least if the actual locking worked. I can include stdio because we're just testing it. Print dash. Okay, what's the error? Invalid operands. Move into register this value. Maybe we can move directly to registers. How do we actually move? Move to register. Why the fuck is it not working? Okay, because we have it as temp, we can mark it as W. Okay. Why is this first line erroring out? What's wrong with this line? Why don't you like it? Maybe it does not like this. And how do we jump? We say backwards or forwards. We say backwards. And B. Maybe that was the issue. I should have put loop B. Well, first let's test if it's working, and then we'll see. Why is it considering this as an opera? Mm-hmm. Labels inside Clang inline ASM. And F is forward. Okay, maybe it does not need this. We don't know. I'll try. No fucking clue. Okay, we'll try that. Maybe for some reason it wants it that way. Now I don't know what to do. So we'll just try whatever that is showing up in our eyes. Oh, now I'm fucking gonna kill myself and then we'll think about it later. Why the fuck is it not working? What the fuck did I do? I just placed the label there. Why is it so fucking hard for you to consider a label? We go for this approach. We go for this approach. Oh, fuck me. Looks like we can't deal with 32 bits, 8 bits. I cannot. I thought I can save some bytes, so fuck it. It's fine. 32 is not gonna kill me. Updated 32 everywhere. I can remove the word then. Holy shit. Holy fucking shit. I fucking hate this. Okay. This issue and what? Okay, at least that label error is gone. I think the label error was just that error, so we can go back to our old setup. Just to have it like this, so it's more readable. I think we can also go back to this loop. Stripes. Okay. We can't have named labels. Okay, that's fine. At least normal label, we get normal labels. And we update bird again. Let's try. Okay, we have status is also a source. What we do, we take whatever is in this memory. No, we take whatever this in this register, write it within this memory location, and we store the results, as in whether we passed or failed, into this register. Interesting errors. We'll ask the best possible solution, and then we'll figure out why it's wrong. Status is also source occurs because instruction cannot use the same register for both status output and its data input. Am I using it that way? Input is 0 and output is W1. Input is this and output is results. How the fuck are they the same? Oh, so this operator does not mean it's a reference. Oh, fuck. Oh, I'm so fucking stupid. So this just means that it will get a separate register. And it fucking works. Let's say if it hangs and 1. Now it should hang because there's nobody updating that register. Yes, it hangs. Now we can start a new thread that will update it after a while. But I guess that is it. It is working. We want to test it with another one. We can import thread and start a new thread. Use thread dot h to write an example to test this concurrent access. We don't have any such things. We are simply gonna start 2 threads and pass the spin lock. I don't have any of that. We start to threads that take a function pointer and execute it. Oh, fuck me. Why can't I have a simple example? Do I have to use memmap? I just want to test this, bro. So, test this lock. That is all. I don't fucking care about anything else. Yes. Let's just implement the unlock operation. And unlock is just the same thing. We just put we read from that same location, and if it is 1, if it is 1, it must be 1. Maybe because we know we just have to unlock it. You can just write 0 to it directly. Write 0 and write it here. Okay. Now we just copy paste this code. Well. We need a global lock, and it's going to be zeroed. And then we have a int volatile int counter equal to 0. And then we need a function that is void star, and it's going to run, and it will it take anything? I don't know. It's not going to take anything because the counter is external, the lock is external, so it's just void. And internally it's just going to go to a for loop int I equal to 0 I less than 25 I plus plus, and we try to lock, spin lock, and lock, and then we increment counter plus equal to 1 and spin unlock. Yeah, hopefully that is all we need. Now we start we print the initial counter value, and we don't do anything. Counter, and we also put it in the end ones, and we can start. How do we create a thread? pthread.h, we create and we pass. We create 2 pthreads. And we create 2 pthreads. Why is it not working? P1 and P2, and we start them. How do we start them? We create pthread create, and we join. Okay, pthread create, and it takes a thread as p1, and we second pointer is thread attributes, and the third is the actual function, and the fourth is the permissions. And we create 2 threads. Do we have to join? I don't think we have to join, but if we don't join it, the main will kill itself. Oh, I have put void pointer. And then it takes void pointer nullable. Okay, so actually we need a pointer. Return 0. So and it should accept void pointer arc. And we put spin lock. Why the fuck did the counter not work? Okay, probably because we didn't join it. Thread join p1 null. Is it good? And put another. Okay, things did not turn out well. There's something wrong with our counter. Let's see if probably it's the unlock that is stuck. Print f unlocked. And it's going to be locked. Let's test this out. Now it worked. Maybe it was just that error. We had multiple return statements that fucked us. Let's just put return results. Now it's not working. But if we put this, it works. That's so fucking annoying. No, it didn't work. Now I get it. Maybe this return result is somewhat fucking with us, because it's just 0. It looks to be working. For some reason. And it, for some reason, it also likes to have this print. So it's definitely memory ordering issue. No, it's definitely memory ordering issue. So if we have this prints, for some reason we are able to return properly and things are working. But if we don't have this, then we're not able to return properly. this operation is, I think I can specify how to tell client not to touch the function. Also inputs. I mean ASM inputs needs to be proper way how to tell the compiler not to make it as pure as ASM. I know there is something. Fucking hell. It's just so fucking annoying. We must have wrote something. It is locked and it's never unlocked. Trying to make function get inline. I think attribute something. Let's search for attributes in our repo. Must be there. Aligned, we have attribute aligned. We don't have. No inline. I think we need GDB. We check if it is 1. If it is 1, that means we need to maybe simply we just what if we simply update it? Without marking, can we update it? I don't know, I don't think so. So let's just load it. And that way we marked that location. Now we move 0 to it and we write it back. Now we get locked. Okay, now we'll remove the locking and unlocking and check if it's working. Why the fuck it is working? It's 2500. Only then we'll know it works or not. Okay, now if we lock it and unlock it, we'll always get the proper value. That's it. Now we have the spin lock that is almost working. And I think the issue was somehow when we read from that value, which is result, it was 0. Okay, yeah, I am setting it to 0 now. What am I reading from? I'm reading from lock. And lock is supposed to be the proper value. And no matter what it is, I'm just writing 0 to it because we want to unlock it. And we only call unlock here. I think it should work. Okay. I'll comment this out. Now we have a proper overall working spin lock. Compare and swap based logic using memory tagging instructions, and we are able to sync it. Yeah, That's it, guys. Today we managed to implement spin lock and spin unlock using the compare and check instruction, and it seems to be working. Tomorrow we'll try to implement it within our kernel, and then also integrate it within our kernel. Also we have to start the user processes so that we'll have multiple things running that can actually show us if things are working or not. Yeah. That's it. Thank you, guys. Bye bye.